Yesterday, I was started rescue and escape reviving apparatus from our AK Gorai, and we have discussed that in the normal scenario, a person need to take 50 breath per minute, and in that process, he will require 1.5 liter O2 per minute. Okay, this is in the new normal scenario. So our apparatus is also we make our apparatus on the this phenomena or these features we include on that. Okay, and then we have started to we have seen the prototype self-contained. This is the prototype self-contained compressed oxygen apparatus, जिसको हम short form में SCBA भी बोलते हैं, and it is a model of the two type model. Two model it has, prototype Proto Mark 4 and Proto Mark 5. I told you both are the closed circuit operation in both the apparatus, and the capacity is different. In the prototype Mark 4, it has a three capacity of 300 liter of the O2 you can compress in it, and it can use up to 2 hours. Or in the prototype Mark 5, it is also closed circuit operation, and it can compress a similar quantity, but it work only 1 to 2 hours. And Draeger self-contained compressed oxygen apparatus, it look like that, and it is also closed circuit operation. It work up to the 4 hour, and up to 4,400 liter of oxygen you can compress in that container. And feeding rate is similar. I told you in the initial that a person in the normal scenario is required 1.5 liter per minute. Okay, and another is the chemical oxygen breathing apparatus, uh, AUER SAR 30. It is also closed circuit operations. It can be used for the 30 minutes only, and in it canister where the KO2 is stored. Like its name, it is the chemical oxygen breathing apparatus. Chemical chemical oxygen breathing apparatus. What it means? So chemical, you use chemical that will react and make oxygen. In Draeger self container compress oxygen, where we compress oxygen in the container, but here you will take we will see the chemical reaction to form the oxygen. Okay, KO2 you will use, and KO2 will react with the water and it will make oxygen. And another was the self rescue breathing apparatus, which is the closed circuit operation and can work for 1 to 4 hours. Its principle is AUER SAR 30. It is also contained in the canister KO2. Now we will see self rescuer and gas mask. Both are the open circuit. Open circuit, that means it will look like that, and you will not store any oxygen in any container. You will directly take oxygen from the environment, because your environment have oxygen, but it was polluted. So you are using the rescuer or gas mask. In both, there are filter which will filter the oxygen, and you can breathe in the fire environment. So where you will use this type of apparatus, it will use where you want to escape from the fire, and it can be used where the carbon monoxide is up to 2%. Both are the open circuit. Okay, where you don't supply O2. And this is reviving apparatus you have seen in the corona also, and in your hospital you can see. Then we have seen airflow through the mines opening. So two types of the flow we see: streamline and turbulent. Streamline, that means laminar. So if the Reynolds number is less than 2000, it will known as the streamline. and if it is the Reynolds number is greater than 2000, you will get a turbulent flow. So the Reynolds, how you will find out the Reynolds number? The formula is Vd divided by V, small v. So V is velocity, d, that means diameter of the duct, and small v, that is kinematic viscosity. Kinematic viscosity, that means mu by rho. Mu is the viscosity and rho is the density. Then pressure drop in the mines we had discussed, that means delta P by RQ square. P is the pressure difference, R is resistance, and Q is the flow in meter cube per. I told you to remember these three formula: P बराबर RQ square, Q बराबर AV, and P बराबर KSQ square by A cube, where K is the coefficient of friction, that means F by 8, and S is the surface area. How you will find out? If this is your duct and this is the perimeter, so perimeter into the length of the duct, you will get your surface area. Then the shock loss at the area changes and the bend, which will be X rho V square by 2. Then we have seen equivalent resistance. If if the resistance in the series, you all you will add all of them. But if they are in parallel, please focus here, because in 12th class we have seen for R equivalent 1 by R1, 1 by R2, that is different. And for the air equivalent resistance, we will consider 1 by root R equivalent equal to 1 by root R1 plus 1 by root R2 plus 1 by root R3 dash. That for the parallel. Then air power is simply uh, you will multiply pressure into the quantity. So pressure is RQ square and Q. So RQ cube. So you can put P value also, KSQ square and by A cube. We will see lot of question on that. And equivalent orifices, we had discussed yesterday that 1.2 Q by root P. So don't remember this, you just need to remember this: A barabar equivalent orifice with 1.2 divided by root R. Why this formula? Because you know P barabar RQ square, so you can convert where. ठीक है, 1.2 root R you need to know. Then we see we have we NVP, that is the natural and mechanical ventilation, in which we have discussed NVP. NVP GDB, temperature of upcast minus temperature of downcast into 10 to power 3 divided by 287 temperature uppercast into temperature of downcast. Motive column we have seen. I told you that pressure is rho gh. We have seen in 12th class, also 11th 12th class, rho gh. So if you want to find out h, that means pressure by rho g, and for here pressure you are taking nvp. So nvp is rho g. To remember, I told you to go in your 11th class and try to recall those formula. Ventilation survey, we have seen that for the in coal mines, for in the coal mines, gassy seam, then you need to uh, ventilation survey in 14 days, and if you have a non gassy mines, then 30 days you have to do the ventilation survey. Then the measurement of the velocity of the airflow we had discussed, which is the smoke cloud method, hot hot wire anemometer, then vane anemometer, velometer, and the pilot static tube, and relative humidity 100 minus factor dBT, the dry bulb temperature minus wet bulb temperature. Okay, so if anybody has any doubt regarding whatever we have discussed yesterday, please comment in the chat box. Otherwise, we will start our. Hi, Harish Chandra. So if anybody has any issue, please comment so we can discuss that. For those who do not have any doubt, they can start. Okay, first we have to discuss this and then we will start our numerical section. Okay, देखो, I told you that the all gas have a specific gravity, and if it is your phase of underground, okay, so if the specific gravity is lesser than air, you will found that gas on the floor side. If specific gravity is less, if specific gravity is high, गलत बता रहा मैं. If the specific gravity is less and high, what it means, अगर मान लो गैस की स्पेसिफिक ग्रेविटी लेस है, दैट मीन्स हल्की है, भारी है, हेवी और लाइट. So if the specific gravity is less, you will find that gas on the roof side. This is roof, this is floor. So now you can say hydrogen you will found near the roof, methane you will found near the roof. Okay, NH3 also found near the roof, but you can also place those gas according to their specific gravity. They can ask you, please arrange these gas according to their floor to roof or roof to floor. So if you know the basic, and SO2 is the heaviest, so it will found near the floor. Then you found NO2, CO2, that is carbon dioxide is also heavy, so you will found that gas near the floor. Okay, SO2, N2O, CO2, and H2S, stink gas. This is the stink gas. So they can ask you the stink gas where you found near the floor, and NO. So basic trick is the sulfur, nitrogen, you will found component you will found near the floor, and the nitrogen N2, CO, NH3, CH4. So in that way you have to practice 2-3 times, so it will stick in your mind, है ना. और इस पे बेस्ट क्वेश्चन आ सकते हैं, है ना, तो आपको थोड़ा बहुत पता होना चाहिए. Okay, first question for you. You have a 30 second. Please participate as much as you can, because these questions are very simple, and we will try to take easy question first, and then we will discuss, and we will go tougher one. Give your answer of question number 1. What is the question? In an underground working area, CH4 and CO2 are normally expected to be found. कहाँ फाउंड होगी? CH4, that means methane. Carbon dioxide, that CO2. So where you will found both the gases? First option is near the floor and along the road. Near the floor, near the roof. Near the roof, near the floor. Along the roadway and near the floor. Please comment your answer in the chat box. And please try to write question number and their answer, so I will know what is your answer is. क्योंकि ये कंफ्यूज कर देगा वरना कि क्वेश्चन कौन सा चल रहा है और आप आंसर किसका दे रहे हैं. सो क्वेश्चन नंबर एंड देयर आंसर, दैट आंसर. सो हरीश चंद, मोनिका, Monica given answer C, Vamsi C, Harichandan C, Mohammed where the roof, and Venkateshwar C, and Vamsi CH4 is roof. Okay, and Vamsi CO2 floor. Okay, and Harish Chandra 1C. So majority of you are correct. Answer will be, you will found, if this is your heading or in the working area, you will found CO2 near the floor and CH4 near the roof. So CH4 near the roof and CO2 near the floor. Answer is C. So go today and try to practice, because nowadays competition is increasing. They may ask you four or five guesses, and they will tell you, they can tell you to arrange from top to down, down to top, that way. Question number second, you have a 30-second. This is a simple question. I have discussed this lot of times. So question is, the oxygen concentration in the underground working should not be less than 30-second. Harichandan, Vamshi, Venkatesh, Sundar, all are giving their answer. Please participate. Answer is C. We have discussed percentage of oxygen, carbon monoxide, carbon dioxide. We have discussed all percentage, and temperature also we have seen. In the covered flammable diagram, 30-second you have. Try to give your answer. Covered flammability diagram, the respective percentage of the methane and oxygen at the nose limit. Go and practice your diagram also. Covered flammability diagram, the respective percentage of methane and oxygen at a nose level. Give your answer. First you have to give answer of this question, and you have to answer the exact range of your whatever I have told you in the class. So participate. Vamsi, Venkatesh, they have given their answer. You are correct, Venkatesh. After the 15% limit, you cannot survive, or oxygen level. Okay, Vamsi and Venkatesh has given their answer for the question number 3, and please give your participate, give your answer as fast as you can. Harichandan has given the range, which is 5.4 to 14.8. But I also told you to give the answer of this question. Mohammad Fakhruddin. Okay, so as I told you, what is the limit? We have seen the diagram is according to this, and this is a 5.4, this is a 14.8. So the range will be 5.4 to 14.8. So it is the range. So 5.4, 5.4 से start होता है. So 5.4, 14.1, 18. So 18 is bigger than 14.8, so you can eliminate. 19.2 is also bigger, you can eliminate. And the 14.2, it can be 5.8, 12. Answer is C, because 5.8 and 12.1 is in this range. Those who are giving the wrong answer, they can correct yourself. Please give question number 4. 30-second. Maximum wet bulb temperature in underground mines. Venkatesh, Sundar, Harichandan, and Vamsi. If it is 30.5. So I told you, the maximum wet bulb temperature in underground is allowed 30.5 degrees Celsius. And I also given information that in the normal scenario, up to 30.5 degrees Celsius, if the temperature is, you need 1 meter per second air. But if more the temperature, you have to increase your velocity. The Another question number 5, 30 seconds you have. The wet bulb temperature of the air at a particular place in a mines in 31 degrees Celsius, then the velocity of air in that place should be more than 1 meter per second, less than 1 meter per second, more than 2 meter per second, less than 2 meter per second. Give your answer. You have 30 seconds. Vamsi has given his answer. Venkatesh, Vinod, Farukuddin. Okay, all are correct. Answer I already told you कि अगर if the temperature exceed then 30.5 degrees, up to 30.5 degree you need 1 meter per second. If the temperature is more than 30.5 degree, you need more air, that means more than 1.1 meter second. So 31 degrees Celsius is more than 30.5 degree. That means you need more than 1 meter per second. Effective temperature is estimated from. You have a 30-second. Effective temperature. Effective temperature. How can you for the estimate of the effective temperature? Which thing you need? Vamsi already given his answer. Please be serious in this class and try to give your answer based on your knowledge. Don't see the answers and giving the answer in the chat box. It is your for practice. Venkatesh also given his answer. And revise as much as you can so it will help you in the examination. One of the person has said if you work hard before the examination, you don't have to work hard in the examination. सो अगर आप एग्जाम से पहले बहुत ज्यादा मेहनत कर लेते हैं तो एग्जाम में आपको कम मेहनत करनी पड़ती है. ओके, वामसी, वेंकटेश एंड फखरुद्दीन given his answer. So as we have as dry bulb temperature we required, wet bulb temperature we required, relative humidity we don't required, so all option is air velocity we required. So answer is C. So for the effective temperature, you required wet bulb temperature, dry bulb temperature, as well as air velocity. Question number 7. You have a 30-second. Give your answer. Match the following: फायर डैम, ब्लैक डैम, वाइट डैम, स्टिंग डैम, गेट 2012. इंपोर्टेंट है ये क्वेश्चन. As everybody may, if you are in mining, you know that fire dam, that means CH4. Okay, and I told you, if you know the question, if you don't know the question, if you know one of the option, try to eliminate choices. है ना. ये क्वेश्चन तो इजी है, आप पढ़ चुके हैं, बट अगर जो क्वेश्चन आपको नहीं भी आता है, ट्राई टू फोकस व्हाट यू नो रिगार्डिंग दैट क्वेश्चन. ओके, so I know fire dam, that means CH4. So S3 only one option, है ना. Then you have to cross check. So sting dam, I know sting dam, that is S2S. So cross check and both is, and if you know only two options, then you have to, whenever you see or revise the previous year, other option you have to also write down if you don't know. So white damp, white damp, that means CO. We have we have seen lot of detection tool, testing tool of the CO. We have seen the properties of the CO. Go and revise that one also. And black damp is CO2. White, black. Quantity of airflow to be circulated to the working depend on. You have a 30-second and Sol. Please give your answer of question number 8. Quantity of air to be circulated to underground working depend on. Okay, the Vamsi, Venkatesh, Fakhruddin, and Harichandan, he has given his answer. So those who have taken the classes seriously, they know that I have discussed these questions and I have revised also that if you for the quantity of air, we consider main power of largest shift as well as production, daily production, and maximum of both will be the our answer. So for the quantity of the air to circulate in the underground depend on the main power of the largest shift. Yes, it depends. And total production of the day is also depends. ये गलत है, पर डे नहीं होता है ना, पर लार्जेस्ट शिफ्ट होता है. सो आंसर विल बी डी. बोथ ए एंड सी इज करेक्ट. Solve this question. Question number 9. You will have 40 seconds. Give your answer. Those who know. Harichandan. Okay. So you all are participating. That is good. And how you will solve this question? As I told you, the number of largest shift is given 150. Okay, and daily production given 500 ton. So I told you for 150%. So for 1%, we need 6 meter cube per second. So we have a 150%. So for that, so 15 छक्का 90, 900 मीटर क्यूब पर मिनट है ये. दिस इज मिनट. 900 मीटर क्यूब per minute. For 1 ton we need 2.5 meter cube ton. So we have 500 ton. So 2.5 multiply 500, which means when you multiply 25 पंजा में 125, 125 0. So meter cube per minute. Okay. So if you calculated air for person and air for your production, and which value you will consider? You will consider maximum of both. Which is the maximum? 12 point. So our quantity of air will be the maximum of choice 1 and choice 2, which will be 12 1250 meter cube per minute. Option will be, so these option will eliminate 1250 meter cube per minute. Okay. Okay. Any doubt in question number 10? Agar question number 9, if you have any doubt, you can comment. Otherwise, we can go to the next question. You have to consider the maximum value between the प्रोडक्शन एज वेल एज मेन. ये ऐसा क्यों करते हैं? अगर कोई कंफ्यूज हो जाए एग्जाम में कि वाई वी आर कंसिडरिंग द मैक्सिमम, बिकॉज in the in the underground, if you are providing the maximum air for this production, it will also sufficient for it, so we are considering the maximum. अरे यार, होता है ना कि अगर आपने सबसे कमजोर बच्चे को ही सिखा दिया तो होशियार बच्चे तो सीख ही जाएंगे. This question we have not discussed. It was not covered in the AK Gorai. Those who know, they can give their answer. Otherwise, I will solve after 30 seconds. Those who have doubt, they can comment in the chat box so we can discuss. Otherwise, those who don't have any doubt, they can solve question number 10. So question number 10. A road header district produced 20 milligram meter cube of the airborne dust with the following size: 1 micromean, 5 micro, 10 micro, 20, 50, 50. So cumulative weight is 1, 5, 10, 20, 50, 100. The concentration of respirable friction of the dust. Suppose this is a person, so we consider the micro, so there will be limit कि कितना आप अंदर inhale कर सकते हैं. So respirable friction, so we use dust mask. Okay, so if you do not have a dust mask in the normal environment, so how much is permissible or how much is they consider? So the gate in 2008 has taken the data. In that time was NCB data. The sample by the NCB, they have considered those particles which are lesser than 5 micro, their weight they have considered. Okay, but in the general scenario, respirable size considered is less than 10 micro. But for the gate 2008, they have considered the micro lesser than 5. So micro lesser than 5 is the 5% weight. So we have to consider 5%. So total dust emission is 5%, 20 milligram per meter cube. Therefore, the concentration of respirable dust friction will be 20 multiplied 5%. That means 5 divided by 100. So it will be 1 mg per meter cube. Answer will be D. समझे कि क्या होता है? जो भी रिस्पायरेबल होता है ना, उन्होंने एनसीबी के डाटा के अनुसार वो 5 माइक्रो को ले रहे हैं, कंसीडर कर रहे हैं. Those who have doubt in question number 10, they can ask in the chat box. Otherwise, they can solve question number 15. This is the respiratory quotation of the breathing for the worker. You can say also it as a grams ratio. You can calculate gram ratio or the respiratory quotient is up to you. A mines working in high normal air where the Exhale air contains 16.65% O2 and 3.83% CO2. The respiratory quotient of the breathing for the worker. You have a 30 seconds to solve this question. Please participate as much as you can. Try, at least give your try. So if you try that question, if you don't know the question and still you are trying, if you own the formula, when you will see the solution, you can know what mistake you are doing. Question number 15. Try to give your answer. Solve. You have 30 seconds. You have to find out the gram ratio or the respiratory quotient of the breathing. Okay. So question number 15. What he asked, respiratory quotient. So respiratory quotient equal to CO2 exhale divided by O2 consumed. So CO2 exhaled. How much exhaled? So a mine inhaled normally where the exhaled air contains 16.65 O2 and 3.35% O2. So 3.83 is CO2 and O2 consumed. O2 consumed. If you want to take, because both all the option are far, so you can consider O2 as a 21. Otherwise, if you want to calculate exact, then you can take 20.995 also. So it's up to you. So 21. So consumed कितना होगा? So consumed कितना होगा? So if it is the person, he when he was inhale O2 in the environment 21%, and when he was exhaling O2 percentage now is 20, reduced up to 16.9565. So that amount of oxygen you are consuming. So 21 minus 16.65. So 3.85 divided by. So when you subtract 21 minus 16.65, it will be 4.35. So you can divide and get your answer. It will be 0.88. Okay. Uh, First, see what is the limit of explosibility of a mixture of the combustible gas. Limit of explosibility, which is the formula is 100 divided by V1 by X1 plus V2 by X2 plus V3 by X3, like that is percentage. So that is the limit of explosibility of the mixture of combustible gases. So यहाँ पे V1, V2, V3, V4, what is the this V1, V2, V3, the volume of different combustible component, which if add all of value, it will be nearly 100. And what is the X1, X2, X3? They are the limits of the explosibility of the corresponding component. So I left this formula when I was discussing the theory, because I thought you will it will be best for you to when I will discuss the numerical. So how you will this formula? So uh, the lower explosibility. So lower explosibility equal to, if you can if you want to solve, you can also solve with me. है ना। कभी कभी क्या होता है, कुछ क्वेश्चन में डायरेक्ट बताने लग जाता है, तो अगर आपको लगता है कि वो क्वेश्चन मुझे ट्राई करना चाहिए तो यू कैन आल्सो सोल्व विद मी, है ना। बैठ के देखने से अच्छा कभी कभी सोल्व करना भी ये ठीक रहता है। सो 100 divided by, what is v1 is 75 divided by, what is x1 is 5. So I can write here v1 is 75, v2 is 15, v3 is 10, x1 5, x2 x2 is 3.3, x3 is 4.2. So 5 plus 15 divided by 3.3 plus V3 divided by 4.2. So a gas of mixture CH4, C2H6, H2 with respective concentration is this of the volume. The lower explosibility limit of CH4, C2H6, H2. These are the lower limits. Okay, and lower the explosibility we are finding out. So 5 एकम 5, 5 में 25, तीनों पंजे 15, 11, 21, 50. So if you find out 15 plus 11 पंजे 11 चौक 44, 15 divided by 3.3, it will be, and plus ये आ जाएगा लगभग 42, 2.38 and 33.15, 15 divided by 15 divided by 3.3. So it will be nearly 4.54. So when you solve all the value, it will be 15 plus 4.54 plus 2.38, 4.56. 10th question. 10th question में according to NCB we have to consider 5 micros. So I have taken 5 micro. So 5 micro size लेंगे तो up to 5 micro, up to, because he has written down that up to size up to 5 micro लेना है, तो cumulative percentage is 5%. So I consider 5 and solve that question. Because NCB guideline के according in 2008 5 micronutrients we have to taken, so we have considered that. Please comment if you have any doubt in question number 18. Those who do not have any doubt, they can try to solve the question number 16. The maximum allowable concentration of the respiratory dust. Just remember a formula for this question. So whenever you want to find out the maximum allowable concentration MAC, which will be per 15 divided by percentage free silica in milligram by meter cube. Just write down this formula also. So whenever you want to find out the maximum allowable concentration, you have to consider this formula. 15 divided by the percentage of the free silica. So now the question is simple. If you know the formula MSc, 15 divided by percentage free silica. So the 4 Indian coal mines, the maximum allowable concentration of the respiratory dust containing 7.5% free silica. So 7.5%. 5, so it is nearly 2 times, nearly क्या approx 2 times, no, exact 2 times, so 2, so 2 milligram per meter cube. So answer will be 2 milligram per meter cube. Question number 21. This will be our last question for today, and try to give answer of the question number 21. Question number 21 or similar question you can find out first. First do to question number 25, then we will discuss the 21. We have seen this question, so try to give you answer of question number 25. You have approx 40 seconds, then we will discuss this question. Question number 25. Give your answer within 40 seconds. I have no answer from your side. This is a simple question and we have also discussed these questions. Please try to give your answer. Question number 25. Divide into parts. First is for persons and second is for the production. For the person, we have to consider that an underground coal mines 550 tons. Production is 520 tons. Okay. And deployed to 220, 200 and 192 in the three shifts. So we have to just focus on the largest shift. Largest shift is 220. So we have to focus on 220. So for one person we need 6 meter cube per minute. So for 220 we need 6 into 220, which means 1320 meter cube per minute. And for the production, for 1 ton, we need 2.5 meter cube per minute. For 520 ton, we need 2.5 multiply 520. So if you want to multiply in the examination, whenever you see 25, you can write it 100 divided by or 10 divided by 4 or 100 divided by 4. If the 25, then 100 divided by 4. यहाँ पे 2.5 तो 10 by 4. 4 एकम 4, 4 तेरी 12. So it will be 300, 1300. So we have two values, 1320 and 1300. So I told you from the choice 1 and choice 2, we have to consider the maximum value. So maximum value is 1320, then consider 1320. Nikhil, Harichandan, and Venkatesh have given their answer and they are correct. And Sundar also. Question number 21. This will be your last question and then we will take class tomorrow. Give your answer in 40 seconds. Percentage of black damp in the area you have to find out. So first is give you an answer which is the gas you found for the black dam you have to consider. Which two gases you have to consider for the black dam. So for hint I can give you information. I think you if you have revised properly you had seen that for the black dam we consider methane नहीं. For the black dam, we have to check nitrogen as well as CO2. Okay, we have to consider the both. Okay, so okay, I will give you the solution how you will solve this question. So first you have to write down all the value. O2 21%, CO2 0.03%, and 2, which is 78.97%. This is the composition of the air. This is the air composition. Now mines composition is also, so O2 in the mines is 18%, he is saying. CO2 is he is saying 2%, and nitrogen will be 78%. Okay, so now you have to find out equivalent. So O2 equivalent, which means 18 divided by 21, 18 divided by 21 multiply 100, so it is 3 छंग 18, 3 सत 21, 7 8 56, 7 नाम 63, सो 7 8 56, 7 पंजे 35, 71%. Okay, and O2 equivalent. Now nitrogen equivalent. Nitrogen equivalent, that means this is the equivalent air. This is air O2 equivalent. It is nitrogen equivalent, that means 18 divided by 21 multiply nitrogen percentage is 78.97. 3 6 18, 3 7 21, and when we multiply all this to this and divide with 7, it will be 67.69%. So O2 equivalent and nitrogen equivalent if you have got, then you have to find out CO2 equivalent. You have to find out the equivalent of air, nitrogen and CO2. So it will be in with respect to oxygen. So CO2 equivalent will be 0.03, and when you multiply CO2 equivalent will come 0.026%. Okay, these are the equivalents. So now for the fire dam we will consider fire dam, not fire dam, black dam. So for black dam, so for black dam we have to consider the excess amount of nitrogen and CO2. So black dam equal to excess nitrogen and excess CO2. नाइट्रोजन एंड CO2 आई टोल्ड यू. सो एक्सेस नाइट्रोजन कितना हो गया, यहाँ पे है 67.69, यहाँ पे है 78. सो एक्सेस, हाउ मच एक्सेस, it will be 78 minus 67.69 प्लस यहाँ पे एक्सेस नहीं होगा CO2 इन माइन इक्विवेलेंट, CO2 इक्विवेलेंट. So excess of nitrogen plus CO2 equivalent. So excess of nitrogen is 78 minus 67.69, or CO2 equivalent. CO2 equivalent which is given, we have calculated, which is 0.026. So it will come 10.31 plus 0.026. When we add up, it will be 10.336. 10.336. देखो अगर यहाँ पे CO2 में कंफ्यूज हो ना, तो अगर तुम ये वाला वैल्यू रखो, दोनों का डिफरेंस रखो, तो भी 10 के आसपास ही वैल्यू आएगी. तो 10 के आसपास ऑप्शन यही है, ये ऑप्शन है ही नहीं. इफ यू वांट आई कैन एक्सप्लेन यू अगेन इफ यू हैव एनी डाउट. क्या हुआ, क्या किए, for the fire dam or black dam we have to consider nitrogen and CO2 excess. Okay, so for the nitrogen excess we have to find out the equivalent. So air का equivalent पता है, mines का पता है, तो mines का हम equivalent ऑक्सीजन के कंपेयर में निकालेंगे तो O2 इक्विवेलेंट 80/21 इंटू 100, ये है एयर के इक्विवेलेंट, and this is nitrogen equivalent, that is 18/21 multiply 78.97, तो ये नाइट्रोजन का इक्विवेलेंट है। CO2 का इक्विवेलेंट 18/21 इंटू 0.03, सो ये CO2 का इक्विवेलेंट है। सो यहाँ से एक्सेस ऑफ नाइट्रोजन निकाल लो, ये भी एक्सेस ही होगा, दिस विल बी आल्सो एक्सेस ऑफ CO2, it will be 0.4 when you minus 0.03 minus 0.026, so it will be 0.04, so it will be 0.10, exact answer. समझे? O2 equivalent, nitrogen equivalent, CO2 equivalent. For the four black dam, we have to consider excess of nitrogen and excess of CO2. That way you can find out. Once more, okay, I will explain once more. Then तो इस क्वेश्चन में कुछ नहीं करना है, जब भी आपको पता चले कि ब्लैक डैम कैलकुलेट करना है, ब्लैक डैम कैलकुलेट करना है, दैट मीन्स आपको पहले पता होना चाहिए कि ऑक्सीजन इक्विवेलेंट, ये जरूरत नहीं है, डायरेक्ट आप करो नाइट्रोजन इक्विवेलेंट एंड CO2 इक्विवेलेंट। नाइट्रोजन इक्विवेलेंट किसके रिस्पेक्ट में? ऑक्सीजन के। सो माइंस, इन द माइंस यू हैव 18% and in the air 21%. So nitrogen equivalent, then you have to consider nitrogen percentage, that is 78.97. CO2 equivalent, then mean 18/21, CO2 percentage is 0.03. So when you multiply, you will get 78.97. So it will come 67.69%, and when you calculate CO2 equivalent, it will come 0.026%, है ना? अगर दोनों इक्विवेलेंट निकाल लिए आपने, और एयर में कितना है? इन द एयर you know nitrogen percentage is 78.97, in the mines 78 point, and CO2 is, so how much it excess? So for the fire dam or black dam, I am sorry for that, बार बार मैं फायर डैम बोल रहा हूँ, गलती है मेरी। सो ब्लैक डैम, for the black dam, excess of nitrogen plus excess of CO2 you have to consider. Excess of nitrogen, that means 78 minus 67.69 plus excess of CO2, which will be 0.03 minus 0.026. When you calculate, it will be 10.31, it will be 0.04. तो यहाँ से जब कैलकुलेट करोगे, ये आएगा वो 10.31 अप्रोक्स। So answer is A.
To watch the complete video, download Mining Gyan 2.0 app from the Play Store and enjoy seamless learning with Mining Gyan 2.0.